Hi everyone, welcome to Learn and Code. In the last class, we have seen arithmetic operators. After arithmetic operators, in today's session, we are going to discuss the remaining operators. First, I'm going to start relational operators in C. Let us have a discussion on relational operators. So, relational operators are divided into the first one is equals to. So, the syntax for this can be given as operand 1 is equals to operand 2. Example, we are writing 5 is equals to 5. So left side 5 and right side 5 both are equals to 5. So the condition it gives is true. The result is here true. True in the sense you can also write 1. Now second operator is not equals to. So syntax is same, operand 1 not equals to operand 2. So in this case 5 not equals to 5. 5 not equals to 5? No, the condition is false and its value is 0. Now third operator is less than. The syntax is same, operand 1 is less than operand 2. So in our example 5 is less than 5. No, the condition is false. Now the result it gives is false and its logical value is 0. Now the fourth operator is greater than. The syntax is again same, operand 1 greater than operand 2. If I take 5 is greater than 5, no, the condition is false. Here also the logical value we get is 0. And fifth operator is less than or equals to. The syntax is again same. Operand 1 is less than or equals to operand 2. So for example, I'm taking 4 not 4 is less than or equals to 5. So in this case, we get true and its value is 1. Now sixth operator is greater than or equals to. The syntax is again like this, operand 1 is greater than or equals to operand 2. So in this case, if I write 5 is greater than or equals to 4, the answer is true and its logical value is 1. So these are the simple relational operators and corresponding examples. After this, we move on to next type of operators known as logical operators. How many logical operators are there in C? There are three types of logical operators. The first one, we write it as double ampersand. It is read as logical and second operator is or, read as logical or, and third one is not. So we read it as logical not. They are the three logical operators. Now for these three logical operators, we are taking again operand 1, operand 2. But the operand 1 is one condition and operand 2 is another condition. Instead of taking simple operands, we are taking in place of operands, conditions we are taking. Now we will see examples for this. First, we are talking about logical AND. In this case, I'm taking the first condition, or I can say operand 1, second one is operand 2, and here the third column I'm taking as the result. Assume that the operand 1 or the first condition is true and second condition is also true. Then the result we get is true. Now true and second one is false, we get false. If any one of the condition is false, the result is false in AND. False, true, we get again false, 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 again we get false. So that means operand 1 is one condition and operand 2 is another condition. Operand 1 is one condition, operand 2 is one condition. If the first condition is true and second condition is true, then this logical AND gives again true. Please remember that operand 1 is one condition and operand 2 is another condition. We're taking two conditions, right? Those are acting as the operands. Now, after logical AND, we move to logical OR. So here also we are taking two conditions in the form of operands, operand 1, operand 2, and here we are taking the result. So in this case, assume that if operand 1 is first condition is true and second one is false, the result we get is true. If any one is true, the result we get true. Now true, true, again we take true. False, true, true. If any one of the condition is true, the condition is true. Next, false, false, the result is false. You can say that logical AND is nothing but product. Logical OR is nothing but simply plus operator. Now, true plus false means 1 plus 0, that is 1. 1 plus 1, again 1. 0 plus 1 is 1. 0 plus 0, the result is 0. So this is the logical OR operator. Next, we move on to logical NOT. Logical NOT, just I'm taking operand and here I'm taking the result. Operand means condition. If the condition is true, the NOT of true becomes false. If the condition is false, the NOT of false becomes true. So this is a simple explanation about logical AND, logical OR, and logical NOT. So with this, we have completed relational operators as well as the logical operators. Remember, relational operators are also binary operators and logical operators are also binary operators. Why? Because they are operating on two operands. So after completing this, next we are moving to assignment operators. What do you mean by assignment operator? How many types of assignment operators are there? There is basically only one operator, one assignment operator, that is single equals to. So it is read as assignment operator. Example, we give a equals to 5. So we are assigning 5 to the value, to the variable a. But this equals to operator or the assignment operator can also be written as in another form. We can write plus is equals to, and third one is minus is equals to, fourth one is star equals to, and fifth one is division equals to, sixth one is percentage equals to. So plus equals to, in the sense, for example, I am writing like this: a plus is equals to 5. The meaning of this is a equals to a plus 5. Similarly, a minus equals to 4. That implies a equals to a minus 4. So star equals to means a star equals to 2. Then the meaning is a equals to a into 2. Now another example, a by equals to 1. That means a equals to a by 1. Modular division, here it is. For example, a modular division equals to 2. That meaning is a equals to a percentage 2. So these are the examples for assignment operators. Not only these operators, you can use left shift equals to, right shift is equals to, and bitwise and equals to, bitwise exclusive or equals to, bitwise or equals to. So that means if I write a double less than shift equals to b, the meaning is a equals to a double less than b. So you have to follow the same instructions which are said above. These are the statements which comes under assignment operators. After assignment operators, we move on to increment and decrement operators. So how many increment and decrement operators are there? So basically there are only two operators. One is plus plus and second one is minus minus. Plus plus is increment operator and minus minus is the decrement operator. So now the plus plus can be either prefix and second one is postfix. Similarly, decrement operator also, it can be either written in the form of prefix, another one is postfix. Prefix means we are taking operand next and operator first. That means plus plus a. Postfix means a plus plus. Similarly, for decrement operator, minus minus a and a minus minus. This is pre-increment and this is post-increment. This is pre-decrement and this is post-decrement. So these are the two forms of increment and decrement operators. So we will see examples for all these operators by using Visual Studio Code, or we write C programs for these operators which explains relational operators, second one logical operators, and increment and decrement operators. We will see examples. Now we will see C program using Visual Studio Code for the explanation of relational operators. So let us write the program for relational operators. I'm writing program for this. Program to implement relational operators. Hash include stdio.h int main opening this. I'm taking two variables integer a comma b, printf, enter any two numbers, slash n, semicolon, scanf, percentage d, double quotes close, comma, ampersand a, comma, ampersand b, semicolon. Now, after reading these two numbers, I'm going to apply relational operators. Why? Because they are binary operators. They require two operands, a and b. Now, printf, I'm writing like this, percentage d equals to percentage d is true or false. I'm giving the result, percentage d, and I'm writing slash n, and after before double quotes, comma, a comma, b comma, first operator I'm using a equals to b, right? Now in the next statement, what you do is just I'm copying the same statement, control C, control V, control V, control V, control V, control V, control V. Now we will change the operators. First one is equals to, and the second relational operator is not equals to. Just I'm writing not equals to. Next, after that less than, next greater than, and next one is less than or equals to, greater than or equals to. The last one is not necessary. I'm removing. A equals to, and another one is not equals to, and the next operator is less than, and this is greater than, and it is less than or equals to, and last one is greater than or equals to. And the last statement you write return 0. So total how many relational operators? Equals to, not equals to, less than, greater than, less than or equals to, greater than or equals to b. Now let us save this program and you run it. So it is asking again two numbers. Now I'm giving the value 5 and second one is 6. Now if you observe the output 5 equals to 6, this is not true. So that's why it is giving 0. 5 not equals to 6, yes, 1. 5 is less than 6, yes, the condition is true. That's why it is giving 1. 5 is greater than 6, no, 0. 5 is less than or equal to, yes, 1. 5 is greater than or equal to 6, yes, 0. So like this, you can give any kind of input. Depending upon the input numbers, it gives the corresponding output. So this is the simple program which explains the concept of relational operators. In the next class, we will see logical operators as well as increment and decrement operators. So with this, I'm going to wind up the session. Thank you for watching.